All right, we're going to talk about measures of center today. So basic concepts of measures of center. Okay, the measure of center is a value at the center or middle of the data set. Okay? The mean or arithmetic mean is a set of data, is the measure of center found by adding all the data values and dividing by the total by the number of data values. Okay, so make sure you're using the word mean. We don't use the word average in statistics. Okay, it's always the mean of it. When you're in elementary, you probably did it by average. That is not how we identify this in statistics. Okay, so use the word mean. A statistic is resistant if the presence of extreme values or outliers does not cause it to change very much. Okay, so the mean, so here's the mean. We have the sum of all of our data values divided by the number of data values. If the data are a sample from a population, the mean is denoted by bar x, or x bar, okay? So if we're taking a sample, we use x bar. If the data are the entire population, the mean is denoted by mu, okay? So you kind of get familiar with this. We're going to use x bar if we're just dealing with a sample of the population. We're going to use mu if it's the entire population. Okay? So sample statistics are usually represented by English letters, such as x bar, and population parameters are usually represented by Greek letters, such as mu. So when we're talking about samples, we're going to use English letters. When we're talking about entire populations, we're going to use Greek letters. Okay, so sigma, this is the sigma. It denotes the sum of all data values. So we're going to add those up. So that's going to be sigma notation. X is the variable used to represent the individual data values. N represents the number of data values in a sample. And capital N represents the number of data values in a population. Okay, so x bar equals the sigma x over n is the mean of the set of sample values. And mu equals sigma x over n, which is the mean of all values in a population. Okay, so example 1. Data set 32 airport data speeds in Appendix B includes measures of data speeds of smartphones from 4 different carriers. Find the mean of the first 5 data speeds for Verizon: 38.5, 55.6, 22.4, 14.1, and 23.1. All in megabits per second, or Mbps. Okay? So what we're going to do is we're going to find the mean. So here's my formula here. I'm going to use x bar because I'm only taking a sample of my entire population. So I have sigma x over little n. So I have 38.5 plus 55.6 plus 22.4 plus 14.1 plus 23.1 all over 5, because that's how many data values I have. So that becomes 153.7 over 5. When I divide that out, I get 30.74. The median. The median of a data is the measure of center that is the middle value when the original data values are arranged in order, increasing or decreasing magnitude. So it's the middle of that value. Half the values are going to be above it, half the values are going to be below it. The median does not change by large amounts when we include just a few extreme values. So the median is a resistant measure of center. So the median, if I took my data values, if I changed the largest value to be 5 times as big, or you know, it's not going to change that median. That median is going to be resistant to change. The median does not directly use every data value. For example, if the largest value is changed to a much larger value, the median does not change. And that's kind of what I was talking about there. It's really kind of looking at pieces of it. Calculation and notation for median. If the number of data values is odd, so we have 5, 7, 9, so on and so forth, the median is the number located in the exact middle of the sorted list. If the number of data values is even, the median is found by computing the mean of the two middle numbers in the sorted list. Okay, so you're going to take the two middle numbers and find the mean. Okay, so here we have 5 data sets, 1, 2, 3, 4, 5. The nice thing, these are already in order for us. So what we can do is we can count here. So 1, 2, 3, 4, 5. 3 is my middle, so 23.1 is my median. Now I have 6. 1, 2, 3, 4, 5, 6. So right here is my two middle. So what I'm going to do is I'm going to add those together and divide by 2. So I'm finding my mean. So I'm going to go 23.1 plus 24.5. I get 47.6. Divide that by 2. 23.80 MPSs. The mode. The mode of a data set is the value or values that occur or occurs with the greatest frequency. Okay? So here's my list of data values. I have 0.2, 0.3, 0.3, 0.3, 0.6, 0.6, and 1.2. Now, the mode is the most common. It doesn't, so we want to pick the most common here. We have 0.3 appears 3 times, so that is my mode. I don't say this one appears 3 times, this one appears 2, this appears 1. So this is my mode. Now, if I had another 0.6 here, so I had 3.3s and 3.6s, I would have 2 modes. Mid-range. The mid-range of a data set is the measure of center, that is the value midway between the maximum and minimum values. Okay? In the original data set, it is found by adding the maximum data to the minimum data value and then dividing the sum by 2. So here's our formula, mid-range, maximum plus minimum divided by 2. Okay, so here's back to our original 5 data points that we've been kind of using, and not arranged in order. So if I want to find the mid-range, I'm going to take the largest, which is 55.6, and the smallest, which is 14.1. I'm going to add those together and then divide by 2. Well, when I add those together and I divide by 2, I get 34.85. Okay, round off rules for measures of center. You probably noticed that I might have had some rounding. So for the mean, median, and mid-range, carry 1 more decimal place than is present in the original set of data. So you notice my original data had 1 decimal point. So when I find my mean, median, and mid-range, I'm actually going to put 2. Okay, so you're going to go 1 more than the decimal in your data. For mode, leave the value as it is without rounding, because this is the mode is the same as some of the original data values. Okay, so it's basically a rewrite of the original data values. Okay, mean from a frequency distribution. Last chapter we talked about frequency distribution. So what we're going to do is first multiply each frequency and class midpoint, then add the products. So here we have our mean equals, so this is we're getting the mean from our frequency. So if remember our frequency would say, hey, we have between 5 and 10, we have 5 values. So what we're going to do is we're going to take the midpoint of that, 7.5, times x, which would be 5 divided by the sum. So this results in an approximation. Okay? So the sum of the frequencies equal to n. Okay, so computing the mean from a frequency distribution. So last one we kind of looked at it. We kind of showed you the formula, and this is what we're going to do. Okay, so if you remember, this is those restaurant times, McDonald's restaurant service times. This is the frequency. Okay, so here's our data set. So we actually figured out this part right here. Okay, so we had this, we had this. Now what I'm going to do is I'm going to put in another column that is the class midpoint. Okay, so the class midpoint is the mid-range between this. So in this case, it's going to be 99.5. Now what I'm going to do is I'm going to take my frequency times my midpoint. Okay, so 11 times 99.5, that gives me 1094.5. And I'm going to do that for each one of these. 24 times the midpoint, 3,588, 10 times 199.5, 1,995, 3 times 249.5, 274.5, 2 times 299.5 gives me 599.0. I want to know the sum of my frequencies. So how many points are there here? 50. I need the sum of all these midpoint times frequency, and that gives me 8,025. Now I'm going to take this sum here and divide it by my total frequency. So 8,025 divided by 50 gives me 160.5 seconds. Weighted mean. Okay, so this is really important when we're talking about when values don't have the same measure to them. So some are weighed or are heavier than others. So weighted mean, so the mean equals the sum of the weights times how many data values over the sum of the weights. So when different x data values are assigned different weights w, we can compute a weighted mean. Okay, so we're going to look at that. So computing grade point average. Okay, this is something that you guys all probably want to know. In her first semester of college, a student took 5 courses. Her final grades, along with the number of credits for each course, were A, 3 credits, A, 4 credits, B, 3 credits, and F, 1 credit. The grading system assigns quality points to letter grades as follows. A is 4, B is 3, C is 2, D is 1, supposed to be 1, sorry, that's a misprint, and F equals 0. Okay, so compute her grade point average. Okay, well, the problem is here our F only had 1 credit, right? So it's not going to affect it as much as this 4 credit one. Okay, so the first thing we're going to do is we're going to take the weight times the data value. So 3 credits times my A, 3 credits times my 4 here, 4 times my 4, 3 times my 3, right? 1 times my 0, okay? And so we come up with 43 over 14, and her GPA would be 3.07. And that's kind of how you calculate weighted mean.